As before, we can consider an object is moving in a circular path of radius r. You can look at it in the picture. This radius is r with constant speed v. As we explained before, the velocity at point A has magnitude v and is along the tangent line at the point A. Similarly, we can define for the point B. So the concept here, one important concept here is that both vectors VA and VB has magnitude same, which is equals to V, but their directions are different. Okay. So let's see here. We define acceleration as delta V over delta T. Okay. So in our case, say this will be acceleration vector will be V2 or VB minus VA over the time interval, say T. I just assumed like delta T time interval is equals to T. Be careful that this VB minus VA is vector subtraction. Okay, be careful about that. We have learned the skill how to subtract vector. If we proceed forward, we get this acceleration equals, means positive value of this acceleration equals v square over r. So this acceleration here is called centripetal. Centripetal acceleration, or we also call it radial acceleration. So this is the only positive value. So we call it magnitude of centripetal acceleration. Okay. This means at the point A, the acceleration will be toward the center. So we write AC to represent, this is the centripetal acceleration. So this can be written as AC to represent it is toward the center, will be P squared over R. At the point B, the acceleration will be toward the center. Say we have the another point, say it will be C here. The centripetal acceleration will be toward the center. Right? So clearly, for all these points, magnitude of centripetal acceleration is v squared over r, but direction is different. You can look at the picture for each point. Okay, for each of these points, for point A, B, and C. This can be further simplified like that. So if you want to further simplify, we can write AC equals V equals R omega, we learned in previous chapters or previous module, squared over R, which can be written as R squared omega squared over R. So centripetal acceleration can be simplified as r and r squared cancel out, so it will be r omega squared. Okay. So the important concept here is that centripetal acceleration is always towards the center at every point of this path. Okay. So we learned here for each point, velocity and acceleration are mutually perpendicular. Mutually perpendicular. This is true for each point. For each point. It could be A, it could be B, it could be C, or any point. If you understand this concept here, you can practice this question.